Every single morning, technical professionals face a massive, invisible tax on their time. You wake up and immediately the data starts pouring in. You check GitHub for what's trending, then Hacker News. Slack notifications light up with archive. Reddit debates new frameworks, alongside articles from dev.to. By the time your coffee is cold, 45 minutes are gone. The engineers building the future often find themselves paralyzed by the sheer volume of information about it. High-performing engineers rely on a trusted filter. Think of a great cafe. You don't inspect the roast or measure the water temperature, you just receive a perfect cup. The barista handled the noise. Personal.cafe is a fully automated, humanless system designed to act as this digital barista. Every single night, it ingests 40 to 60 trending technical items and distills them down into exactly 3 high-signal briefings. Engineering a system to process noise on behalf of the user preserves precious cognitive load for actual development. At the pipeline start, at exactly 2 in the morning, an automated cron job wakes the system. A Python script executes, fetching data from 4 upstream APIs simultaneously, pulling in 40 to 60 raw data points. This introduces a data hazard. GitHub, Hacker News, Archive, and dev.to each return different data structures, keys, and formats. The pipeline runs a normalization step. Every disparate item is forced through a single formatting funnel. They emerge as a universal flat structure, where every item contains 5 metadata tags: title, summary, URL, source name, and timestamp. Enforcing this strict structural uniformity at the very moment of data ingestion allows the system to smoothly apply advanced mathematical sorting downstream. With the data normalized, we face the problem of semantic redundancy. If a major AI model releases, all 4 sources cover the same story. Passing redundant news to a large language model increases latency and degrades the final user experience. Instead of expensive compute, the pipeline applies TF-IDF vectorization. This converts text into a mathematical vector representing the specific meaning of the words. To compare stories, cosine similarity measures the exact angle between 2 vectors. Smaller angles mean closer meaning. The engineers set a precise programmatic threshold. Any similarity score above 75% triggers a duplication flag. When the system inevitably breaches that mathematical threshold, the lower quality redundant item is permanently dropped from the final payload. Deploying mathematical vector comparison before the LLM layer separates robust data pipelines from fragile AI wrappers. Only the top 25 deduplicated items reach the AI synthesis engine, routed through the Open Router API. For this specific synthesis step, the pipeline calls the NVIDIA Nematron model. Left to their own devices, LLMs often introduce hallucinations, fluff, and conversational prose into curated content. To prevent this, the system prompt assigns a strict persona, an editor for CTOs and staff engineers, instructed to write with a sharp, analytical tone. The model is explicitly forbidden from using marketing hype. Words like revolutionary, game-changing, and groundbreaking are struck out in the prompt instructions. Furthermore, the LLM is forbidden from returning standard paragraphs. It must deliver its final output as a strict JSON payload. That payload must contain 3 specific keys: the espresso shot, the cold brew, and the daily pastry. This layout is enforced using pedantic schema validation. The POD acts as a mechanical boundary, ensuring the output exactly matches the contract. If the model returns malformed JSON, an automated retry loop attempts the process up to 3 times to achieve perfect formatting. Reliable AI in production requires treating the large language model as a heavily constrained, deterministic formatting function. Once validated, the JSON payload is archived into a Supabase Postgres database. Row-level security policies ensure this historical dataset remains protected against unauthorized access. The Fast API REST backend acts as the gateway for the frontend, serving stored data. The API exposes specific endpoints: /pipeline/log for execution history, /digest/history for past records, and the primary /digest path. Finally, the Next.js frontend calls the primary endpoint to retrieve and render the day's payload. The user is presented with a cafe-themed sub-second loading interface that updates every single morning without any human intervention. Completely decoupling the automated ingestion pipeline from the stateless front end ensures consistent speed and reliability. This flowchart displays the entire end-to-end system in sequence, from raw API ingestion through normalization, vector deduplication, LLM synthesis, and final delivery. This architecture runs entirely serverless, executing daily with zero human oversight. Combining vector mathematics with rigid schema validation provides the blueprint for solving information noise. Future versions of this platform will add individualized curation, allowing users to define their specific tech stack interests. This seamlessly scales to the enterprise level, generating automated, team-wide morning briefings aligned with a company's specific architectural focus. Every knowledge worker deserves an automated barista that filters the internet for them. Building deterministic engines capable of extracting only the pure signal provides a technical solution to modern information overload.